Alright, so now we're going to be having a look at question 20. So this is question 20 from the 2020 HSC Advanced Maths paper. So this is a question about the use of a numerical method. So it says Kenzo is driving his car along a road while his friends record the velocity of the car vt in kilometres an hour every minute over a 5-minute period. The table gives the velocity vt at time t in hours. Now, for anyone who takes engineering or physics, kilometres an hour and then denominating time in hours as fractions because you're actually trying to denominate it in minutes immediately seems very bizarre, right? So the presentation of the numbers in this question will seem unusual to some students, but we will be using these numbers, right? We don't need to change them to meters per second or anything like that. So we're told the distance covered by the car over the 5-minute period is given by the integral from 0 to 5 on 60 of the velocity as a function of time with respect to t. Use the trapezoidal rule and the velocity at each of the 6 time frames to find the approximate distance in kilometres travelled in the 5-minute period, 1 decimal place. So we're going to be using one of the only numerical method formulas on the HSC formula sheet. This is actually in the integrals section. This is sometimes called trapezoidal rule, sometimes called one of the numerical methods more generally. The integral of a to b f of x dx is equal to b minus a over 2n times f of a plus f of b plus 2 times f of x1 plus dot 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 plus f of xn minus 1. So this is our approximation formula. Really all we're going to be doing is plugging in all of these values. So we have to work out f of a, n, b, f of b, all of the intermediate f of x's from our table. And the table is going to give us all of them assuming we know how to use it. So the integral we're trying to find goes from 0 to 5 on 60. This means that a is 0 and b is 5 on 60. Now, we need f of a and f of b as well. Well, f of a, if a is 0, is going to be 60. This is because when time is 0, velocity is 60. We're told this in the table. So f of a will be 60 when a is 0. So the f of a we plug in will be 60 and the a will be 0. The b, the f of b that we're trying to find, this is the velocity when time is equal to 5 on 60. Well, the table tells us that this is 67. So we have the f of a, which is actually f of 0, which is 60. We have the f of b, which is actually f of 5 on 60, which is 67. We also need the n value. So in this particular question, there are 1, 2, 3, 4, 5, there's 6 pairs of points. 0, 60, 1 on 60, 55, 2 on 60, 65, and so on. The n is usually going to be 1 less than that. So it's going to be the total number of points minus 1, or it's going to be, so this will be the same number. You could say it's the number of intermediate values, all the values between the two n values plus 1. So 1 greater than the number of intermediate values. So in this case, n will be 6 minus 1, which is 5, or 4, the 4 intermediate values, plus 1, which is also 5. So n is going to be 5. Now, all of these values, f of x1 plus f of x2 plus f of x3 and so on, these are all of the time velocity pairs which are not the end points, right? So the starting time velocity pair is 0, 60. The ending time velocity pair is 5 on 60, 67. We need to ignore these. These are all of the velocities in the middle. So, and it's the sum of them. So this will be 55 plus 65 plus 68 plus 70. So we now have all of the values we need. This means we can now plug them in. The integral from 0 to 5 on 60 of vt dt is equal to b minus a, that's 5 on 60, minus 0, so that's just 5 on 60, divided by 2 times n, that's 10, times f of a plus f of b. f of a is 60, f of b is 67, so that's 127, plus 2 times this sum of numbers up here. So 55 plus 65 plus 68 plus 70. So now we just need to literally the entire thing can just go in your calculator at this point. This is right at the end of the question. So once we put this in the calculator, this gives us 643 over 120. The question tells us give your answer correct to one decimal place. So we're going to convert this. 643 on 120 is actually equal to 5.3583 ... So this is 5.4 to one decimal place. And this is the answer that we're after here. So this is a slightly unusual process. When you first see the question, you see the integral and you think you're going to be doing integration. You're not actually doing any integration in this question. This is a numerical method. You are just finding values from the table or from the question, plugging them into your trapezoidal rule formula, your numerical method formula on the HSC formula sheet, and then solving. All right? So there's no actual integrations going on here. These types of methods are fairly common in higher level calculus, especially for those of you who will study things like finance or engineering, things like that, any disciplines in which differential equations are involved. Sometimes you can't solve differential equations nicely. You have to approximate them. And if you're approximating them, you're going to be using some kind of approximation method. These methods are sometimes, but not always, called numerical methods, and trapezoidal rule is an example of a numerical method. The marking here is pretty straightforward. So if you attempt to use the trapezoidal rule, you write down the formula, you start plugging numbers in. This bit is going to get you 1 mark. In order to get the second mark, you will need to successfully use trapezoidal rule, get the answer, and round it correctly. Right? They have made a big deal about saying it has to be rounded to one decimal place. So you have to do that in this instance. This is very important. If you don't, you're unlikely to get the answer mark.